Good morning, everyone, and welcome to Levitt-Safety and Haas webinar on the ANSI Standard 358.1 with respect to emergency eye wash and shower. My name is Mike Douglas. I'm the Market Segment Manager for Levitt-Safety for this product category, and Levitt-Safety is very pleased to have you on the line with us, and hopefully this is a very educational and concise 30-minute session given by a gentleman by the name of Justin Dunn with Haas. Justin's been with Haas for a number of years, 4 years, I believe, and provides a lot of expertise to Levitt-Safety and to end users and customers alike, providing these webinars, surveys, and has a great passion for this industry, specifically coming out of the information technology. So kind of an interesting background for Justin. We have you on mute. If you have any questions at any time, please type them into the chat box, and we will get to them near the end or right at the end. As I said, this should be 30 minutes, and then we'll go to a Q&A. I'll turn it over to Justin now to take over, and again, thank you for joining us.
Good morning, everybody. I want to say thank you for having me, allowing me to do this and to talk about ANSI and the Z358.1 standard, how it applies to you and us and across the world, and explain everything that you need to know about the standard to help you to best utilize the standard. So I really appreciate this. And before we get started, I wanted to cover a couple things before we get into the meat of the presentation. So to begin, that's my face. I'm Justin Dunn. I'm a sales product specialist and trainer for the Haas Corporation. I have been doing this for 4 years now, specifically focused on training around the ANSI standard, even other standards like the ADA, as we manufacture drinking fountains as well as emergency first aid equipment. So any opportunities for education and things like that is what I jump on. So situations like this, so I'm very glad to be here. Now our topics today are going to include what is the ANSI standard. I'm going to go over the standard in depth, explain everything that's required, and exactly the reasons why you should be referencing the ANSI standard in your facilities. I'm going to go over the 2014 revision highlights, all the changes that they made in the most recent revision, what the significant requirements of the standards are, best practices for emergency equipment. I run a survey program with Haas Corporation, and I've just seen the most bananas, crazy stuff you've ever seen as far as emergency equipment goes. So I've learned a lot from that. I'd like to share some of that with you. And then we'll end with a Q&A session, answering all your questions. So as they come to mind, please feel free to ask questions using the questions panel on the screen there. So to begin, I wanted to talk very briefly about CCOHS. Now, in the U.S., we are held accountable by OSHA, or the Occupational Safety and Health Administration. Our OSHA standard is 29 CFR 1910.151C. Super easy to remember number. Now, many provinces and territories use a version of their own. I've seen the Workplace Safety and Health Act, the Occupational Health and Safety Act, and others. And around the world, we all have some organization that uses some combination of occupation and health and safety. Even their requirements for emergency first aid equipment is pretty much the same across the board. Usually states in a very brief way that if there is a potential for exposure, then first aid equipment must be in place for quick flushing. And the biggest issue with these is, and where ANSI standard comes in, is that none of them define how we accomplish this. It just tells us we have to have equipment in place. Now, currently, the ISCA/ANSI Z358.1-2014 standard is used all around the world, from India, parts of South America to Australia. The only other truly comprehensive standards that I think I've seen is the EN standard Europe is using, and then which was formerly the Z358.1 standard. And China, they'll be releasing their new version of their standard soon. Now, federally, this is all that I found on the CCOHS and their requirements. And I spoke to a member, and they referred me to this statement on their website, and it says, consult your local occupational health and safety agency in your jurisdiction and check relevant legislation for any requirements to install this equipment. Currently, there is no Canadian standard for the design and replacement of eye wash stations or emergency showers. As a result, ANSI standard, which is a pretty basic sentence, I was saying that you don't have a standard currently. We're using the ANSI standard, which is the case around the world. Most of the world references the ANSI standard for emergency first aid. Now, the message behind the ANSI standard, the CCOHS, OSHA, whatever your organization is number one, reducing injuries and fatalities. That's first things first. Reducing general workplace risk, and then reducing lost time and money for both the company, your place of work, and for the employee that may have been injured. The faster we can get them to work and out of the hospital and better and living their lives, the better. And that's what the ANSI standard really truly accomplishes, is we're taking into consideration victim comfort. So if you're attending this webinar right now and you're interested in the ANSI standard, I can already tell, and I already know that your interest in the ANSI standard goes beyond your typical requirements. You're interested in workplace safety and helping people. So I did a lot of research leading up to this webinar and learned as much as I could about provincial and territory regulations in Canada. For example, I learned that the Z358.1, although not always the correct version, is referenced directly as the documentation for emergency eye wash and shower performance in Saskatchewan, Prince Edward Island, Nova Scotia, Newfoundland, Labrador, New Brunswick, Alberta, and in Manitoba. While some areas like British Columbia, they kind of develop their own requirements. While they aren't as comprehensive as the ANSI standard, they do make for a safer work environment, and that's why we're all here. The areas where I found the least amount of information was in the Northwest Territories, Yukon, and Nunavut, I think is how you pronounce that. They just add a paragraph mentioning the need for emergency equipment, which is interesting. This map in particular, I just wanted to give you an example of what we're dealing with in the US and how seriously this is taken. Because we do the exact same thing. We reference the ANSI standard. There is nothing in law in black and white saying you have to follow this or you're going to get in trouble. So moving on, the ANSI standard itself was written by the ISEA, and it defines emergency eye wash and shower design, location, and temperature requirements for proper functionality and usage. Again, OSHA and the CCOHS and your individual territories and provinces, they just reference the ANSI standard for compliance. They say, if you want to meet this, our one phrase, our requirement, reference the ANSI standard and you can accomplish that. Now, ANSI was first published in 1981. It's been revised 5 times since, in 1990, 98, 2004, and 2009, and in 2014. That's the most recent and current revision of the standard. In 2009, it had some of the biggest changes: temperature range for water delivery, simultaneous use, and eye wash testing requirements. I'll go over all of those. And then in 2014, were more changes that were geared towards manufacturers of emergency equipment and how it's installed in your location. Now for the significant requirements of the standard. All right, here we go. So first, it needs to be accessible within 10 seconds. Now they added an addendum to the standard saying that the distance between the hazard and the piece of emergency equipment had to be 55 feet. 10 seconds was really hard to judge. All of us move at a different speed, and we wanted a measurable distance. So that measurement, it's 10 seconds or 55 feet from the hazard to the location of the emergency equipment. It needs to be located on the same level as the hazard. We don't need to create an obstacle course for somebody who is panicking, who's having an emergency first aid situation, and they need to get to emergency first aid equipment. We can't have changes in level. We can't have obstacles in the way like garbage cans and things like that. The thing about emergency equipment is, you buy a piece of emergency equipment, it goes in the corner of your facility, and hopefully you're testing it once a week, but it sits there for a long period of time. And generally what I see is it ends up accruing garbage cans and other crazy stuff around it, and it's forgotten. And in the event of an emergency, somebody's gonna have a real hard time getting to it. So make sure it's on the same level as the hazard and that it is free of obstructions. Now, when it comes to obstructions, the number one question I usually get at the end of the webinar is a door an obstruction? And the ANSI standard touches on this. Now, a door is an obstruction, but you're allowed to have one in place if it meets certain qualifications. So the hazard itself has to be non-corrosive, okay? It has to be a non-locking door. It has to be push bar activated, and it has to open in the direction of towards the emergency equipment. So as long as it meets those requirements, you are allowed to have a door in place. Now, the area needs to be well lit and identified with highly visible signage. Okay, we want it to be as easily identifiable as possible. The equipment needs to go from off to on in 1 second or less, and it needs to remain on without the use of the operator's hands. So he needs to be able to turn on the equipment, and he's going to have other things to deal with. He needs to remove his clothing, he needs to hold his eyes open, and then deal with any other situation. So it's got to remain open. There is a misconception with this in the standard that often people think this is it needs to go from off to on in one motion, and that is false. We do have certain areas that require one motion. I'm not sure where those are in Canada. We have several states in the U.S. that require this on the state level, but not on the federal level. So make sure to reference what that is locally. It needs to deliver flushing fluid for a full 15 minutes, but this does change. Now, 15 minutes is the minimum, but there are SDS sheets out there, safety data sheets out there that reference a much longer period of flushing time for corrosives, for alkalis, things that are much more damaging to the skin, may take longer to rinse off of your skin, etc. So make sure you're referencing your SDS sheets to know how long of a period of time that you need to keep somebody in that piece of equipment. Oftentimes, when first responders arrive on the scene, they will force that individual to finish their flushing before they remove them to a first aid facility, and that's because if they're taking you out too soon, and they risk the potential to contaminate themselves. Now they're dealing with two emergencies at the same time. They need to make sure that you're completely flushed off, you're not getting damaged by whatever that material was any longer, and can take you away. Now, the emergency equipment needs to provide a controlled flow of flushing fluid at a velocity that is low enough to be non-injurious to the user. Okay, and that goes for all flushing fluid coming out of the equipment. So the eye wash, the eye face wash, or the shower. It needs to be non-injurious. This person needs to stay in this equipment for 15 minutes. Okay, not to mention they're going to have potentially corrosive, damaging chemicals on their skin or in their eyes. We don't want to provide an eye wash flow that's blowing out the back of their head. I like to call those brain washers. Or showers. I mean, can be subjective, but if it's dumping 30 plus, sometimes 40 gallons per minute on top of you, it's not going to feel good, especially on skin that's already damaged. Now, if you have shutoff valves that are installed in the supply line for maintenance purposes, you need to take provisions to make sure that they are not shut off by personnel in the facility. So lock them out and make sure that only maintenance peoples in your facilities have the key to deactivate these lines. So we don't want somebody walking by and accidentally turning one off, not thinking about what they're doing, or being not thinking about the situation and what it is that they're turning off. Now, all drench showers, they need to provide a column of flushing fluid at 20 inches wide, at 60 inches above the surface floor of the user. So whatever surface the user is standing on, this is just average human body width at the shoulders. And that's just making sure that the flow pattern from the shower is going to reach you shoulder to shoulder and is going to rinse your entire body off. The flushing fluid column pattern, I didn't fix that, and it says pattern. Dang it. So it should be between 82 and 96 inches above the surface floor. Okay, so that's the bottom of the nozzle of the shower. That's what we're measuring to. So not the column itself, but to the bottom of the shower head. We need to make sure that is between 82 and 96 inches. If it's too low, you're going to have a really narrow pattern coming out of that, or patter coming out of that shower head. And if it's too high, the pattern is going to be too wide, and you're not going to get enough water flushing your body off. Now, the pull rod for that equipment, it cannot exceed 69 inches from the floor, and that's to the bottom of the pull rod. And the logic behind that is because if you could put that pull rod too high for somebody, but you can't put it too low. And that's just to make sure that the shorter amongst us are able to reach the pull rod no matter what. We're not having anybody that's having difficulty activating the equipment. Now we have specific requirements for the flushing fluid and how much water we need to be delivering per minute. So I hope everybody appreciates this. I converted this entire webinar over to liters and metric measurements just for you, Canada. So eye washes, the flow must deliver a minimum of 0.4 gallons per minute or 1.5 liters per minute to meet the minimum. Eye face washes, since you have an eye wash, an additional flushing pattern for your face as well, needs to meet a minimum of 3 gallons per minute or 11.4 liters. And a drench shower must deliver 20 gallons per minute or 75.7 liters. And remember that these are all minimums. So technically, you're allowed to pump out a lot more than this. But again, we need to take into consideration victim comfort and making sure that it's not too much or we're not providing an injurious flow. Okay, now combination units must be capable of operating simultaneously, maintaining sufficient pressure and volume to the eye wash or the eye face wash and shower when both are activated together. This is single-handedly the biggest issue I see in the field in almost all equipment I run across that don't use integrated flow controls. You have the shower that's pumping out 20 GPM plus, and an eye face wash or an eye wash that's requiring a lot less, and the path of that water is going to take the path of least resistance through that equipment. It's usually the shower pumping out all that water. And if it doesn't have a flow control in it, it's going to steal all the water from that eye wash or eye face wash, and we're going to make we're going to force somebody to make a very bad decision, whether they want to save their eyes or their skin. We need that equipment to operate at the same exact time. Now, it needs to be positioned so that the components may be used simultaneously by the same user. So you have to be able to use the eye wash, the eye face wash, or the shower all at the same time. They're not meant for separate situations. They need to be lined up. Now, the flushing fluid needs to cover the areas between the interior and exterior of a gauge at some point less than 8 inches above the eye wash nozzle. Now, the gauge that you see on the top right there, that was given to us by the ANSI standard. They provide us with that. And then the one you see in the video here is an example of one we developed. That's 8 inches above the nozzle. And as you can see, the eye wash streams line up perfectly within those circles. And that's based on average human eye spacing. So we're making sure that no matter what, at some point under 8 inches, those streams are going to line up with the eyes, and they're going to be able to use this effectively. Now, all the nozzles, outlets, and stored flushing fluid must be protected against airborne contaminants. So basically, you just need to have dust covers in place. Anywhere where flushing fluid may be exposed, you have to have a dust cover in place. So for portables, you have to have a tank on the lid. On eye face washes or eye washes, you have to have that dust cover in place covering it up. All eye washes, eye face washes, combination units, all equipment have to deliver tepid flushing fluid between 60 degrees Fahrenheit and 100 degrees Fahrenheit, or 60 degrees Celsius and 38 degrees Celsius. This range is really very important, again, to victim comfort. Again, you're in this equipment for 15 minutes. So if we're below that 60 degree or 16 degrees Celsius mark, we're risking hypothermia, and other bad situations on top of what we're already dealing with. If we're over that 38 degrees Celsius or 100 degrees Fahrenheit, then we're risking scalding the skins, the soft tissue of the eyes. In general, our home showers are pretty comfortable. I like mine particularly hot, but I'm not going to look up and stick my eyes in it. It's not going to feel good. This is just a general groundwater map that I like to include to explain Obviously, it's the US. Just imagine everything above this is purple and really, really cold. Um, but it changes wildly. So make sure that you're aware of what your groundwater is in your area so that you can compensate that with hot water heaters, with instantaneous heaters, mixing valves, things that you're going to need in place to help make sure that you're providing tepid water to the victim. Now, tepid water is important because number one, it encourages the use of the safety equipment. If it's too cold or if it's too hot, it's going to drive that person out of the equipment. And I've heard horror stories of coworkers having to hold fellow employees in the equipment um, because they wanted to leave. It was way too cold or it was way too hot, and we don't want to put somebody in that situation. It encourages the removal of your contaminated clothing. Now, this is so important because once you're covered in corrosive or other chemicals that are going to damage your skin, it's going to get trapped between the layers of your clothing. So you got to get down to your birthday suit. Contaminated clothing has to come off of you to make sure that you're rinsing your skin off directly. Okay. It encourages the full 15-minute drench. It cools chemical burns within this area. Again, if it's too hot, we're just making the situation so much worse. And it prevents chemical absorption by keeping the pores on our body closed. If it's too hot, our pores are going to open and it could do even more damage to the skin, depending on what you're dealing with. And again, too hot, we're risking severe scalding, increased chemical reaction. Too cold, and we add hypothermia to the mix, which can be dangerous since we're essentially, or I should say potentially losing the outer layers of what is the insulation for our body. And if we're adding hypothermia to that, the situation could get really bad really fast. Now, where the possibility of freezing conditions exists, the unit shall be protected from freezing, or freeze-protected equipment shall be installed. You're familiar with what you have at your facility, your average temperature ranges. Make sure that you're checking seasonally what it is that you need in place, because obviously we have different times of seasons, temperature ranges that are not going to affect or necessitate the need for freeze protection. But for example, the unit on the right, this is a 8317 CTFP. It's a heat trace unit to make sure that the unit itself isn't going to freeze. So obviously making it dangerous situations. If we get ice in those pipes, it's going to clog the heads or clog the piping entirely and make the unit unusable entirely. So we need to make sure that we're checking that we have equipment in place to prevent freezing. Make sure you're training those who may be exposed. Employees who may be exposed to hazardous materials shall be instructed in the location of and proper use of emergency showers. So if they're working in a particular area, make sure that they understand how that equipment works, how to get to it, and how to test it too. Put that on the employees in that area. Test your equipment, even if you're handling a particularly dangerous situation. Just do a quick bump test, turn it on and off, make sure it's working, and then get to work in that area. But make sure that they're trained on how to use that equipment, especially if they're working in an area where they haven't worked before. So the changes in the 2014 revision included that emergency showers need to be designed, manufactured, and installed in such a manner that once activated, they could be used without requiring the use of the operator's hands. I mentioned this earlier, but I like bringing it up again because self-closing valves were a very popular trend for emergency equipment back in the day, and I still find a lot of them out there. They have to be replaced with a stay open valve to make sure that equipment can be used without the use of the operator's hands. Now it needs to be arranged so that the flushing fluid flow pattern is not less than 33 inches and no greater than 53 inches. This is how we prevent injurious flow using a measurement. That flow pattern from the eye wash or the eye face wash, it cannot exceed 53 inches high and cannot be below 33 inches. We're measuring to the top of the flow pattern, the top of the water. Now, this used to be 45 inches to the top of the eye wash head, which was bad. We weren't measuring the water at all. Anything could have come out of it and we'd be compliant. Now we have to be within that range, 33 inches to 53 inches or 83.8 centimeters. and to 134.6 centimeters to make sure that we're within that range for compliance. The heads also need to be 6 inches or 15.3 centimeters from the wall or any obstruction around them. We don't want somebody going to use the equipment and then hitting their head and potentially, again, making a bad situation worse. So there's, in the appendix in the ANSI standard, there is an installation consideration. On the right, you'll see a big yellow booth. This is our Haas integrated booth. And what we realized and why this had to be added to the standard was we cannot manufacture this equipment without making a step into that equipment. They realized we can't make this flush with the floor. And this equipment is too important to work all around the world for us to just say, okay, well, we can't use this anymore. Or this is non-compliant. So we had to make an exception. So one single step is allowed, because remember earlier I mentioned that we cannot have a change in level. A single step into an enclosure is allowed, but it has to be an enclosed piece of emergency equipment, okay? Where the absence of that enclosure exists, we're not allowed to have that step. So make sure that you're checking that you have enclosed equipment where you have that exception. Now, weekly testing and annual testing. Weekly testing is so simple. Oftentimes I'll go to a facility and my first question is, are you testing your equipment? And the answer is almost unanimously yes. And I know you're lying to me. I know you're not telling me the truth. Minimum requirements are so simple. It needs to be turned on. The equipment needs to stay on long enough to clear the dead leg in the piping. And that's pretty much it. You just need to make sure you have water to the heads of the device. It turns on, and you've cleared out that dead leg in the piping to make sure you're not getting growth and other things in there. And that's it. It's a super fast test. We have testing kits that can help you with that, but this has to be done on a weekly basis. A lot of companies are still using monthly, which would be non-compliant. And then, of course, there is the annual inspection. An annual inspection is the entire gamut of what I just went over. The equipment has to be tested for 15 minutes. You have to measure the pull rod, the shower head, the streams for the eye wash or the eye face wash. Everything has to be measured, and it has to be done for a full 15 minutes. This is very hard to accomplish. Not all of us have drains near the equipment. There are no drains required in the standard. So we need to make sure that we capture that water somehow. Not all of us have areas in our facilities where we can just let 260 gallons of water run wherever we want. So you need to find a way to successfully do this inside of your facilities. It's important to make sure this equipment can function for that long. A couple best practices I wanted to cover real quick before we end up getting to the Q&A. The equipment should be located in areas with adequate space for emergency responders. We need room for them to work on you after you're out of the equipment. And then train your employees on how to access and activate the equipment during the emergency. Okay, quiz your employees, ask them to identify the nearest piece of equipment and how to use it. That can be a really helpful tool. This is more of a bragging point. This is actually ANSI Z358.1. And I just wanted to remind everybody that red, emergency stop, yellow, tripping, falling, striking hazards. I've learned that ANSI Z535.1 is used in Canada too. Orange, parts of machinery, equipment that can cut, crush, or otherwise injured. And then green, the location of safety equipment, just like a certain manufacturer that is giving you a webinar right now. Just saying. The correct equipment for the hazard. Number one, eye wash, wood shavings, dust, airborne particulates, anything that is going to just affect your eyes without being corrosive or affecting your skin. Eye face washes are for minor incidents affecting only the eyes and the face. Drench showers are for PPE decontamination primarily. These are designed for flushing off potential hazards on the outside of your PPE. And then a combination unit, this is perfect for any situation. This is hopefully an eye face wash with a shower. It rinses off your whole body and is appropriate for any and all situations. Make sure you're providing beyond tepid water. 60 to 100 degrees is great, or 16 to 38 degrees Celsius. But if you've ever been in 16 degrees Celsius water, it's still not terribly pleasant. That's still really cold. Make sure that you're providing somewhere in between that range, as close to the middle as possible. Again, just for victim comfort. If it's too cold, again, average residential shower is about 40.5 degrees Celsius, but that's still pretty hot. Certainly for the soft tissue of your eyes. Temperatures in the lower end can affect your heart. You can go into cold shock, possibly leading to cardiac arrest, and then again hypothermia. On the high end, Legionella grows between 95 degrees Fahrenheit and 115 degrees Fahrenheit. Hopefully, unfortunately, this falls into an ANSI range. That 95 degrees Fahrenheit would be compliant. But we need to make sure that we're providing as close as possible to a median in that range for victim comfort and to prevent things like this, like Legionella. Remove your contacts. Don't rub your eyes in a bad situation if you get anything in them. Disrobe completely, including your socks and shoes. Provide privacy curtains and a privacy gown for coworkers and their modesty. Bump test before high-risk tasks, and be cautious while assisting to not contaminate yourself. Make sure you're verbally guiding somebody during a first aid situation. And then I'd like to encourage everybody to use the link at the bottom of the page. This is a complimentary emergency shower and eye face wash survey. The statistics that you see on the right side of the screen are incredibly accurate. This is from our own findings and from an independent evaluation of 1,000 plus emergency units. The big Pac-Man size piece of that pie right there, that 78% says performance related, and that means that the equipment was not providing first aid. The shower wasn't working, or the eye wash or the eye face wash wasn't working. Only 12% of all the equipment that we surveyed was compliant. Obviously, it was all Haas equipment, but the other 10% was non-compliant for an other reason, meaning it was missing a sign or something similar. What this includes is a 1 full day of inspections, an inspection report, an executive summary chart like you see on the right, recommendations on how to fix the issues that we found, a debriefing meeting or web conference with the person who conducted the survey to explain all the findings, and but restrictions do apply. So if you're in a really remote area, we'll do our best to get to you, but sometimes it's just not possible. So make sure that you use the link below, register, contact us, and we will be happy to survey your equipment and help to improve your safety culture in your building there. And that's it. That's pretty much, that's ANSI Z358.1. We will include our contact information at the end of this webinar after the Q&A session, so that you can contact us with any further questions or help that you need in your facilities, or certainly a survey of your site. So please feel free to use that information when we put it up on the screen. And thank you very much for letting me talk to you about this standard.
Thank you, Justin. Appreciate the presentation. Some great information. We've had a couple questions come in through the chat box, so I'll fire away if I could.
Yeah, please.
First question, Justin. With each ANSI update, there's existing product or equipment in the field. Does that equipment need to meet the latest and greatest ANSI standard?
So in a lot of standards, a grandfather clause is included. That is not the case in the ANSI standard. There is no addition of a grandfather clause. Whatever the most current revision of the ANSI standard is, currently the 2014 revision, that is what we need to be using for compliance and for our equipment. So we need to make sure that we're on the most current revision. The past standards, they might as well not exist at this point. We only have the one that we reference.
Okay, thank you. There seems to be a lot of questions around temperature. I guess temperature control options. What's out there for people to look at it to make sure that they're within that range as stated in the ANSI standard?
Technology has come so far now. It used to be, when we first implemented this, it was much harder to accomplish a tepid range for water delivery for emergency equipment. We have to pump out so much water so fast compared to residential or even some commercial applications. So there are just so many options in place right now. We have instantaneous heaters. We have instantaneous heaters that take advantage of the steam that you already have in your facilities. We have mixing valves that will pump water out in a tepid and stable range for you consistently throughout that full 15-minute flush, or however long it has, hot water and cold water for however long your SDS requires. So mixing valves, instantaneous heaters. We have self-contained equipment that is heated and protected and will pump out tepid water. So there's just a myriad of different types of equipment out there for compliance. So it's really pretty easy to accomplish these days, although it, maybe a little bit expensive.
It looks like we've had a couple questions on the drain or drainage of the water. If a drain is not available, what are the options? Is both hot and cold water required, and also with mixing valve? So I guess they're asking a couple different things there. What have you seen in the field for drainage and controlling the water flow when you're doing your 15-minute annual?
So with that, yeah, that was a lot of questions tied into one. So there's nothing in the standard requiring drainage. That would be based on local plumbing code, and you'd have to reference that. Oftentimes, there's no drain in place. I really highly suggest taking advantage of testing kits. It's usually a bucket and a sock that goes over the shower. You can test the equipment, capture that water, and then take it somewhere to dump it. In the event of an actual emergency, that water is going to go where it needs to go. You're dealing with a lot of water over 15 minutes. It's going to damage drywall, sensitive equipment nearby. So take a good hard look at your area, what you have in place, and try to plan around a potential emergency, because oftentimes there's no drain in place. Hopefully the equipment's outside and you can let it run for however long you want, and that water can go wherever it wants. But oftentimes we have schools, we have hospitals, we have places like that have this emergency equipment in place. And if you don't have drains, there's no way to capture that water effectively while somebody is using that equipment. So take into consideration the area, again, sensitive equipment and things like that around the shower or the iFace wash.
Further to the drainage issue, can people build like a cement or some type of dike around their shower, or is that in sort of against what ANSI is saying about obstruction?
Well, sometimes I like to call it a necessary evil. Remember, we don't want to create tripping hazards, obstructions, anything preventing or making it harder for the victim to get to the equipment. Oftentimes that's a barrier around the equipment trying to capture that water. But unfortunately, sometimes what it is that it's capturing is necessary. We can't let that run wherever we want. Could continue to do damage to other people or equipment or somebody trying to respond to the situation. So again, it's going to be non-compliant if you have a barrier or a tripping hazard in place for the ANSI standard. But sometimes we have chemicals and corrosives that are so dangerous that they have to be captured. And again, it's just a necessary evil. So pay attention to your SDS sheets and what's required. And at any point, anywhere possible, really try to provide a flat, clear surface to the piece of safety equipment when you can.
Okay. Looking at portable eyewash bottles, can they be refilled with either tap water or distilled water and still be compliant?
I don't think I've ever been asked that before. No, don't do that. Those bottles are typically filled with either a special fluid, or they are sealed and will prevent any growth inside of the bottle for until expiration date. If you fill them with just tap water, the likelihood that you're going to have growth in that bottle, you don't have a specified expiration date if you fill it with tap water. I mean, it can be done, but I would highly not suggest it. I would suggest buying new bottles, putting them in place in respect to the expiration dates on the bottles.
Keeping with sort of the portable theme, how often do portable units need to be tested?
So similar to plumbed equipment, it has to be every single week. The requirements are just a little bit different. So on portable equipment, if we activate it, we're going to have less water in that equipment. We're going to have less time. We're not going to meet our full 15 minutes. So if we're testing that on a weekly basis, unless we're refilling it every time that we test it. So portable equipment is special. All you have to do for portable equipment on a weekly basis is go to the tank, open up the equipment, make sure that it has a full 15 minutes of water left in the tank. There's usually a mark inside the tank or outside the tank letting you know. Or if it's a cartridge type equipment where you have a cartridge of water that goes in, as long as it's not punctured, you know you have a full 15 minutes there. Typically that equipment though, if you puncture it, it's going to run the full 15 minutes out. You'll have to replace the whole thing. But make sure that that equipment, it just has to be visually checked. That's all. You don't have to activate the equipment at all, whether it's an overhead tank or a portable small tank.
Kind of a maintenance question here. How do you eliminate corrosion in lines, water lines, I presume?
Oh, I'm going to turn into a plumber on this webinar. So I would weekly testing, making sure that you're clearing out those dead legs. We're not giving the water in those pipes the opportunity to sit there and add growth to the pipe and things that are going to further damage the interior of that piping. So making sure that we're clearing it. We have running water in that pipe every now and again is a good way to prevent that corrosion.
The question is, when do you need showers versus just eye wash or eye and face wash stations?
Oh, that's a good question. So again, eye washes or eye face washes, they're great for situations that are only dealing with particulates or really low pH type chemicals that are just going to affect the soft tissue around your eyes or your eye tissue. Anytime that we're dealing with a corrosive or a skin irritant, we have to have a shower in place, and typically a combination of the both. The likelihood that you're going to get sprayed with a chemical and it's only going to go in your eyes or only on your skin and not in your eyes is just not a possibility. So I always suggest an eye face wash and a shower. A situation where you would need a shower in place would be PPE decontamination. We don't want to plan for a situation where you might not get something in your eyes. And that's going to end up with somebody having a really bad day. So make sure showers, PPE decontamination, combination unit is perfect for any situation, and then eyes and eye face washes, perfect for airborne contaminants that get in your eyes that aren't going to damage the skin. Check your SDS sheets, most importantly.
Okay, and I think we'll make this the last question, Justin. I'm going to ask you to look in crystal ball and foresee any new updates for ANSI and what that might be in your opinion or Haas's opinion.
Oh, sure. There's quite a few. I like to keep an eye on it as best I can. One that seems really likely would be a narrowing of the tepid water. 100 degrees isn't so bad, but 60 degrees Fahrenheit is still really cold water. And even at 100 degrees Fahrenheit, I mean, I guess that could still make a situation worse. They could react with a chemical on your skin. They'll probably narrow that tepid water filled by a little bit. 75 degrees Fahrenheit is, and I wish I could come up with Celsius off the top of my head. I'd love to tell you I didn't cheat and Google every single one of those measurements I gave you earlier in metric and Celsius. So, but probably a tepid water range. I'd be surprised, but it's been talked about that they may add a requirement for drainage. The issue is that would be such a dramatic change for all of us to provide drainage to these pieces of equipment and around them that I've heard of the potential, but it's unlikely. And then adjusted measurements for the equipment, stuff that would be more geared towards manufacturers of emergency equipment. For one, redoing the range for the eye face wash heads, further narrowing the margin for injurious flows to eye washes or eye face washes because it's so common. But stuff like that. Those are the three things off the top of my head that I can think of that may come up.
Terrific. Thanks, Justin. That's good information to keep in the back of our minds for sure. I think that's the end of our webinar, our presentation today. Justin, thank you very much. Very informative. Learned a little bit, which is the whole point of this exercise. And for anyone on the phone, if you sent in a question and we didn't get to it, we will follow up and answer all questions. A recording of this session will be made available and sent to all. And as Justin mentioned earlier, if you're interested in a review, there was a link that you could click on. We'd be happy to help you out, review your program, and provide any annual services that may be necessary. So the contact information is up on the screen there. Thank you very much, and have a great day.